Hi everyone, good morning. Today is February 20th. So today we will continue with session 2.4. And when is your exam? Wednesday. So Wednesday I will be here at 9:50. So I know you might have a class before. So after your class finish, run faster around this room and then you can start your exam early. Okay, everybody? So we have a exam. Let's see. So we have the exam seating charts, uh, announcements. Okay, so this is our exam seats. Okay, so you find your name, exam rules, you come in, and then you put your things in your backpack and put your backpack in front of the classroom. You can keep water, pencil, calculator, scientific calculator, no graphing calculator. Okay? Yes, and your cell phone in your backpack. Okay. So you take the exam on Wednesday. Try to come here early so you can start the exam early. I want to give you more time. So you stay here until like 11. I have a class right here at 11. Okay. And tonight, review session. Okay. Promise me you will join. So it's gonna be in Blackboard. You click Tab Live. Okay. You click Tab Live and then uh, click this. Okay. Join this virtual classroom. Okay. So that is the review session. And I really hope all of you do the practice exams and make sure you understand every steps on the practice exam. Because I showed you last time, right? My previous classes, if students didn't do the practice exam, they fail the exam. So practice exam is really, really important. So you know what type of problems will be on the exams, and then you can study for it. All right. I have graded your quiz 2. So this is the quiz 2 solution. Um, yes, this quiz, many of you did well. Okay, many of you get 10 points. Really good. So keep up the good work. I hope you can do well on the exam. And expect that the exam is harder than your quiz because usually quiz is just 5 to 15 minutes and your quiz is more time. So your exam will be harder. Okay, the first one, we want to solve the equation. So we multiply by the LCD, but the LCD here is just x, right? If you have rational expression, write on the LCD. And you need to write that least common denominator is not equal to 0. And then you can multiply by the least common denominator and solve for x. And you check, oh, x is not 0. So this is the solution. Okay, this is quiz 2. I saw several of you didn't take the quiz. So make sure you take the quiz from now on. We have 7 quizzes. We dropped the 2 lowest. So I have some students didn't take quiz 1 and quiz 2. So make sure you don't miss any more quizzes. Okay, that is the first problem. And then the second problem, we have the rectangular room is 1.5 times as long as its wide. So that means the y, if we let the y be x, then the length is 1.5 times x. And then perimeter is 25 meters. So add them up together, 1.5x plus x plus 1.5x plus x altogether is 25. So we get 5x equals 25. X is 5. Okay? And then 1.5 times 5 is 7.5. So the dimension is 5 by 7.5 meters. Okay, so that is the quiz solution. How about quiz mistakes? So it's still the same file, okay? We have quiz 1 mistake and now it's the quiz 2 mistake. So here, the mistake is 3w plus 2w is 5w, okay? This is addition, not multiplication. Be careful. And then After you get to the 5, width is 5. Length is 1.5 times width, not 2 times width. Okay, so check your work carefully. And then here the mistake is length is 1.5 times width. It's not 1.5, okay? It's 1.5 times width. Therefore here is 3 width times 2 width. Altogether give us 5 width. Okay, so yeah, and that's the mistake. Okay, and this is the 2 kind of mistake. Any questions on quiz 2? Okay, so I also realized some of you didn't do all the homework. So go to your, if you go to your Blackboard and you click My Grades, then you can see your homework scores. So right now, you have submitted homework 4. If you don't get 10 points, so some of you submit images. Please combine your images into a PDF. If your images is like that, rotate your images so that it's readable. And please make the pages larger. I saw some students, the PDF is like one page with multiple images on one page, and it's so hard to read. So make your pictures bigger. So one picture per page. Okay? You might have a PDF with multiple pages. And you also need to check your work. That's why I give you the solution. So why do I give you solution? So you know your mistakes, right? After you look at the solution, please use red pen. Do you have a red pen? Use red pen to check your work. If you are correct on the problem, put a check mark. Sometimes I saw some of you circle your answer. Does that mean you check your work? Okay, it's not clear for me. Okay, so if you check your work, please put a check mark. If you have mistake, pause it and write a correction next to it. Then you can get 10 points. So please check your grades. If you do not get 10 points, you can resubmit to gain those points. Okay, so I allow you to resubmit and gain those points back. And then, so that's your homework. And then you can also see your quiz. Do you have your yeah, did you take a quiz? If no, then you cannot make up your quiz. Quiz cannot be taken. So, but we drop the 2 lowest. Just make sure you don't miss any more quizzes. And then the practice exam 1. So you first do it. How many of you have started your practice exam? Okay, good. Remember, I told you some of my students do the practice exam several times, 3 times. Okay, so this is a practice exam, and then after you finish it, you use a red pen to grade your work. And also, you need to estimate your score. How many steps you have reached, subtract how many mistakes you have made. Estimate your score, and then add them up to get a total score. I want you to compare this score and your actual exam score. Have you improved? Okay. And then, so tonight, our review session, we will go over the practice exam. Okay, everybody? Yes. Okay. And any questions so far? Everybody good? Okay. All right, so let's continue. So last time we talked about increasing, decreasing, and domain and range, and relative maximum, relative minimum. And then I asked you to do this practice at home. Because math is really a lot of practices. Oh, that is the attendance. And because we have, Friday I went to a conference, so no Friday. Thank you. Yes. And because we have limited class time, so we couldn't do many group work or practice in class. But I really hope you can do those at home. And if you have questions, feel free to ask me. Okay, average rate of change of a function. So if you drive at 100 miles in 2 hours, what is your average speed? Well, we know speed is distance over time. Distance is 100 miles. Time is 2 hours. So 100 over 2 is 50 miles per hour. So that is the average speed. By the way, so this is the formula sheet. Okay? Everybody get the formula sheet? Please make sure you can memorize this formula. That is really the basic, okay? The foundation. Speaking of math, we're like building houses. So the formula sheet, these basic formula, is like the foundation. You need to have a good foundation, and then you can do the problems on top of it. Build more stories on top of that. So that is really, really important. Make sure you figure those out. Okay. All right. And then here, average speed, we use the distance over the time. And you can think of, this is like a slope, right? So it's change of y over change of x. So, okay, yes. So the average rate of change is like the slope, okay? So if we draw a secant line, so secant line passing through those 2 points on the graph. This is secant line. And then the slope. Slope is change of y over change of x, right? Change of y is, so we have 2 points. This is A, f of A. This is B, f of B. So change in y is f of B minus f of A over change in x, which is B minus A. Okay, everybody? So this is the rate of change formula. Now, example 5. Find the average rate of change of the function 1 minus 3x squared between x equals to -2 and x equals 0. Okay, so average rate of change. Okay, let's get back our orange color. This is so this is change of y over change of x. So f of the second point. In this case, the first point is x is -2. The second point, x is 0. So f of the second point, 0, minus f of the first point, which is -2. All over the second point, 0, minus the first point, -2. Is that okay, everybody? We have 2 points. Yeah, this is -2, and we don't know this number. And then the second point is when x is 0. So change of y over change of x. So f of the second point, 0, minus f of the first point, -2, over change in x. So 0, the second point, minus -2. And then what is f of 0? Well, you look at the formula, f of x. F of 0 is replace x by 0. Right, everybody? So, therefore, we get 1 minus 3 times x. X is 0. See? 0 squared. This is f of 0. Minus f of -2. So don't forget to put parentheses. Thank you. And then we plug in 1 minus 3 times x. What is x? -2. -2 squared. Right? This is f of -2. Common mistake. Students forget the parentheses. If we forget the parentheses, then this sign will be wrong. Because if we break the parentheses, minus actually becomes plus. So parentheses is very, very important. Okay. Denominator, 0. What's minus negative become become positive 2. Okay, numerator 3 times 0 is 0. And then break the parentheses. Minus 1 minus negative become positive 3 times. What is negative 2 squared? 4. Not negative 4. Right, everybody? So 4 all over 2. What happened? Yeah, 1 cancel. 3 times 4 is 12 over 2? 6. So the average rate of change is 6. So far, so good, everybody? So use change of y over change of x. That's it. Okay. Yes. The average rate of change is the difference quotient. It's change of y. This is change of y. So after you draw the picture, then you see, oh, we have the first point is x. Second point is the a. So, and then here we have f of x and f of a. Change of y is f of x minus f of a. And then change of x minus a. And the average rate of change on the interval is the difference quotient. So if we call the first point, so this is like 2 pictures. The first picture we call this is to be a, and the second point we call it be x, and then let's say our graph looks like that. And then we draw another picture, we call the first point be x, call the second point be x plus h, and then we also draw it. Then in this case, let me look at this picture. Change of y. The change of y is f of the second point minus f of the first point over change of x. Do you see change of x? What's the difference between them? Just h, right? Yes. So this is a change of y over change of x. It's the slope of the secant line passing through those 2 points. And this concept is very important in calculus. How many of you need to take applied calculus 1? This is just you? Okay, so make sure you get this topic right. Okay. All right, and here's some practice, and I will let you to do at home. Okay. Even and odd function. How many of you have heard even and odd function before? Raise your hand. Okay, that's all of you. A function is said to be what if the graph is symmetric with respect to the y-axis. Symmetric with respect to the y-axis. It's an even or odd function. Even. Very good. Okay, so this is an even. A function is even if its graph is symmetric with respect to the y-axis. Example. Okay. Example. This is y equals x squared. Okay. And you can see this is a even function because it's symmetric with respect to the y-axis. Right? Applied on the graph. You take a mirror image about the y-axis. That point is also on the graph. Okay. And then a function is said to be odd when its graph is symmetric with respect to the origin. With respect to the origin. And what does that mean? So for example, x equals x cubed. So this point, if you rotate 100 and so this is the origin, right? You rotate 180 degrees about the origin, that point is also on the graph. Okay? So that is symmetric with respect to the origin. You rotate 180 degrees about the origin. Okay. Formal definition. So those are the graphs. We have those properties. Formal definition. A function is said to be even if f of minus x equals f of x. Well, what does that mean? Okay, think about it. Let's call this point to be x, right? And then where's minus x? Well, this is x, minus x is on the other side, right, everybody? Do you see they have the same y? Okay, y is the value on the y-axis. They have the same height. They have the same y. So f of minus x and f of x, they have the same y. They are equal. Then the function is even. How about our function? F of minus x. So let's say this point is x, and then this point is the y, and this point is minus x. Can you see here? This point you rotate 180 degrees. But this here and here, same distance. But this point is below the x-axis. That's why this is negative. So this is negative y. Yeah. So therefore, if a function is an f function, then f of negative x, f of negative x is negative y. Negative y is negative of the y. Y is f of x. So f of negative x is negative f of x. Okay, everybody? Mm-hmm. All right. Determine whether the following function is even, odd, or neither. So it could be neither odd nor even. Okay. Unlike integers is either odd or even. Okay. But for function, it could be neither. So how do we check? We plug in negative x. Okay. And let's plug in negative x. Let's see what happens. So, and whenever you see x, replace x with negative x. So we get 4 times negative x, parentheses. Don't forget the parentheses. Okay, cube minus 7, parentheses, negative x. So don't forget parentheses. If we forget the parentheses, then we'll get wrong. Okay, questions. What is minus 1 cubed? Minus 1 cubed, is it 1 or minus 1? Minus 1. Yes. So here we get minus 4x cubed. Is minus 1 cubed? Is minus 1. And you put the minus in front of the 4. You don't want to put it back of the 4. It becomes 4 minus x cubed, right? It's 4 times negative x cubed. So you can put the minus in front of the 4. Is that okay, everybody? Minus. What's minus? Minus becomes positive. Right? Okay, let's compare to the original function. Are they the same? No, but do you see if we factor out a minus, we get 4x cubed minus 7x. This is exactly negative f of x. Yeah, this is negative. Oh, this is exactly f of x. So we get f of negative x equals negative f of x. F is even or odd. Even or odd. Look at the definition. Odd. Yeah, very good. So f is odd. Oh, so we factor out a negative. Okay. Then we get 4x cubed minus 7x. Yeah. That's exactly f of x. Oh, okay. See? Oh, okay. What's the relationship between f of minus x and f of x? If it equals to f of x, then it's an even. Okay. If it equals to minus f of x, then it's an odd function. If it's not equal to any of those, then it's not. Okay. So we're talking, so we're trying to You kind of simplify the business and then you compare with analytics.
Okay, so it's kind of simplifying compare with
Yeah.
the actual.
Right. Exactly. Good. Okay. Questions?
So if we're able to factor out.
So the goal here is to compare with the original function. So if the original function is not factored, then you don't need to factor it. Yes. Because you can compare. See, it is here, this one is exactly this, then you don't need to factor out. Okay. Yes. This is a good point. It really depends on what we want to do with the function. If we're looking for x-intercepts, then you want to factor out. But in this case, we just want to know whether it's an even or odd function, then you plug in negative x and compare with elements. Yes, very good. Okay, part B. So we plug in negative x. So whenever you see x, replace it with negative x. Don't forget the parentheses. Right? Replace x by negative x. Okay, questions. What is negative 1 to the 4? 1. Oh, so the other these negative disappear. Because negative 1 to the even power is just 1. Right, everybody? So we get 5 x to the 4th minus x squared plus 1. Okay, compared to the original function. What happened? They're the same. So this equals g of x. If they're the same, what do you say? Yes, it makes it even. So g is an even function. So far, so good, everybody? Okay, we keep going. H. So h of negative x is replace x by negative x. So negative x cubed plus negative x squared, and then minus 1. What is negative x cubed? Negative, what's negative 1 cubed? Positive or negative? Negative 1 cubed. Negative. So we have negative x cubed, right? How about negative x squared? Positive. Okay. We simplify it. Compare with this. Are they the same? No. The x squared and the minus 1 are the same. But the x cubed is not the same. Right, everybody? You see, oh, this is not equal to h of x. How about how about negative h of x? Negative h of x is we flip the sign of all of them, right? You see, negative h of x. Okay, negative x cubed, that match. But the other two terms do not match. Therefore, it's also not equal to negative h of x. Therefore, this is neither. Okay? So in the exam, if I ask you a question like, it's not in your exam, maybe your exam 2, then you have to show it's not equal to f of x. And it's not equal to negative h of x. Therefore, neither. Neither odd nor even. Okay? Yes. Good. Okay, 2.4, library of parent function. This is so important. Okay. And knowing the shape of some common functions, this is so important. Okay, first one. I want to show how you get the shapes of these functions. Okay, if you forget the shape, it's okay. Plot points. Okay, so you have your x, you have the y. Usually we pick the point 0 first. here, f of x equals to x. So y is x. So whenever you put 0 here, you put the 0 there, right? Y is x. And so that's why is this point. When you plug in 1, y is x, so it's also 1. So 1, 1. X coordinate is 1, y coordinate is also 1. Then we have this point. And let's do more. How about 2? Okay, 2, 2. How about the negative side? We plug in -1, I get -1. We plug in -2, we get -2. You see, we get this line through the origin with an angle at 45 degrees. Right, everybody? So this is a line, a straight line. Actually, for line, 2 points can fix a line. So you just draw 2 points and you connect and you get a line. You don't have to plug in so many points. Okay? And then here, x squared. X squaring function. Okay, let's draw the table again. Y is x squared. So we plug in 0. 0 squared is 0. See? 0, 0, this point. 1 square. 1. 2 square. 4. Oh, you see? 2 square is 4. And you connect those points together and get this shape. Right? It's like a U shape. How about on the negative side? What's -1 square? 1. -2 square? 2? 4. Yes, that's why it's a U shape. Okay, like give me a hug, right? Okay, that is x squared. How about x cubed? So x and y. Okay, 0 cube. 0. 1 cube. 1. So pass through 0 and pass through 1. 2 cube. 8. Oh, so when x is 2, our y is 8. Up there, right? So 8 right there. -1 cube. -1. Oh, so see, it's below the x-axis down there. -2 cube. -8. So this is a picture, right? Right, like that. Very good. So please try your best to remember the shape. If you do not remember the shape, it's okay. Plug numbers. Okay. So here, x, 0. What's square root of 0? 0. Yeah? Square root of 1. 1. Square root of 2 is not an integer, right? 1.414 something. What is the next x value you plug in, you can get an integer? 4, right? So when you plot points, please plot integer points. So plot integer points. Square root of 4 is 2. So good. You can draw the graph. So the graph look like that. Can you tell me what is the next x value you can plug in to get integer? 6. Square root of 6 is that integer? 9. Yes. Square root of 9 is 3. Right, everybody? How about negative? Can I plug in -1? No. See? -1 is complex number. It's not a real number. Right, everybody? Therefore, we have our domain. Domain for square root of x, okay, is greater or equal to 0. So 0 to infinity. That's the domain, not all real numbers. Okay, everybody? Keywords. Keywords. So keywords. Keyword. Keyword of 0 is 0, right? Keyword of 1 is 1, right? Keyword of what is the next number you plug in, you get an integer. Keyword of 2 is an integer? No, 8. Right, everybody? Keyword of 8 is 2. Right, everybody? So we plug in 8, we get keyword of 8 is 2. So that's why. How about negative side? What's keyword of -1? -1. Okay. By the way, when you work with your calculator, you cannot plug in negative number for the base. Okay. If your calculator will say error. But you know the keyword of negative number is still negative. You can put a minus sign in front of the keywords. And how about the next point? You see that is keyword of -8 is -2. Okay, so it looks like that. Absolute value. Well, we know absolute value is always greater or equal to 0, right? So that's why you plug in 0. Absolute value of 0 is 0. You plug in 1. Absolute value of 1 is 1. You plug in 2 is 2. But what's absolute value of -1? 1. What's absolute value of -2? 2. Therefore, we get a V shape. Okay? Right. So this is the absolute value function. And reciprocal. Okay. So x and y. 0. Can we plug in 0? No. 1 over 0 is undefined. Therefore, do you see as 0? There's no point. The function is not defined as 0. Okay? How about plugging 1? 1 over 1 is 1. How about plugging 2? I get 1 over 2, which is 1/2. Right, everybody? And if you plug in 1/2, you get 2. So therefore, it looks like that. How about on this side? You plug in -1. 1 over -1 is -1. You plug in -2, you get -1/2. So your picture looks like that. Okay, everybody? So that is the reciprocal function. So similarly, you can draw the square of reciprocal. You plug in 1, you get 1. But when you plug in 2, 1 over 2 squared is 4. You get 1/4, which is lower. Okay, everybody? You also connect them. But this case, because it's square, when you plug in -1 squared is 1. Right? So therefore, this is an even function. You see this is an even function? Because when you plug in -x squared becomes x squared. So this is an even. And greatest integer. This is the greatest integer. So that's why you plug in, let's say you plug in 0.5. What is the greatest integer that is less than or equal to 0.5? You get 0. Okay? And when you plug in 2.3, what is the integer that is less than or equal to 2.3, which is 2? Okay? So we get like this pear shape function. This is the greatest integer. Okay, so which one you need to know? You need to make sure you know those 6. Okay, everybody, move your hands up. Let's do math move. Line. Okay, line. So everybody, line, like that. Yes, like that. And then grab up. Like a U shape. Execute. Yes, like that. And square roots. Yes, keywords. Okay, absolute value. Okay, do this exercise every day. Not only exercise, but also remember the math moves. Okay? Do you know there are some T-shirts like that? Okay, let me show you. Okay, you can maybe buy a t-shirt. Let's see, math move t-shirts. Okay. Let's see, which one? Yeah, like that. X squared. Oh, x squared plus y squared is circle. Yeah. And square root. Oh, 1 over x. Yes, 1 over x, like that. And sine, cosine, like you will learn that in applied trigonometry. But in our course, we don't talk about trig functions. Okay. So those are the math moves. Okay. Okay, so that is the library of functions. Okay, so everybody close your eyes. And when I say the function, you move your hands. Okay, close your eyes. Absolute value of x. Yes. X squared. X squared. X squared. Like a U shape. U shape. X cubed. One hand up, one hand down. Square root of x. Yeah, on one side, on the same side. Yes. And then cube root of x. Cube of x. One hand out, one hand down. So cube root of x and x cubed are similar, but this is very high. You move your hands high. And then this one, you move your hands. Your shape is like that. Okay, everybody? Okay, yes. So in the exam, so not exam 1, but exam 2, if you really forget about the graph, plot the points. See how I get this graph by plotting the points and connect them smoothly. Then we can get the graph. Okay, very good. Now, how do we graph piecewise function? So last time we were giving some x values, we evaluate the piecewise function. But today, we need to graph it. Okay, so look at the domain. Well, domain is the x values. Look at this. We have -1. Do we include the -1? No, and it's to the left or to the right? To the left, less than, to the left. And then the second piece, so this is the first piece, right? We're using the formula x squared. The second piece, we're doing what? 0. Do we include a 0? Yes, left or right? Right. So this is the second piece, right? The domain, we say, by the way, in the exam, express your answer in interval notation. So minus infinity to -1. Parentheses or brackets? Parentheses. Union, okay, like a U, but you don't write on the tail, right? And 0 parentheses or brackets? Brackets to infinity. Right, everybody? So that is the domain. Now, how do we graph the function? Okay, so gotta have the x-axis. This is the x-axis. And then we have the y-axis. Okay. And then the first piece. What's x squared look like? Yeah, like a U shape, right? So without the pieces, we know it looks like a U shape. But now we have the pieces. Let's look at the endpoint. -1. Okay. So when x is -1, what's -1 square? 1. So we know the point is here. But because this is x less than, which means we do not include the endpoint. Then you put an open circle there. So put an open circle. Okay? So open circle because we don't include the endpoints here.
Then how about -2? What's -2 squared? 4, right? And 4 right here. And then we connect them smoothly. So it looks like that. U shape. See? It's like a U shape, but we only restrict to x less than -1. Okay, everybody? We only restrict to this part, this piece. Okay. And remember, if you don't include the endpoints, put an open circle. And then this is the first piece. Second piece. It starts from 0. And you see the power of x is 1. Then you know this is a line, right? Power 1, linear function is a line. How many points can make a line? How many points you need to make a line? 2. So we just plug in 2 points. And look at the endpoint. Endpoint is 0. We plug in 0, what happens? 2 times 0 minus 3 is -3. So x is 0, y is -3. Open circle or solid circle? Solid. Okay. Because we include the endpoints. So that's 1 point. Give me another point. Let's plug in. How about when x is 1? 2 times 1 minus 3 is -1, right? Oh, -1, which is right here. And 2 points fixed on line. Connect them. And we get the graph. Okay, everybody? So we plug in the endpoint and then the graph together. In your exam, please label the important points. So don't just put a bar there, because what is your scale? What does 1 bar mean? Is it 5 or 1? So label the important points. Is that clear, everybody? Raise your hand if you can hear it. Label the important points. Everybody hear it? Okay, good. Okay, any questions about example 1? Good. Example 2. All right. Now let's see. We have the x-axis, and then we have the y-axis. Here we have 3 pieces. Okay. The first piece, x less than equal to -3. Okay. Where's -3? That's 0. That's -3. And do you see what's the power of x? 1. So it is a line. How many points can make a line? 2 points. So we plug in the endpoints. Plug in -3. Oh, x, which is -3. Right? -3, -3. Which is, oops, I don't want to erase it. Okay, so which is -3 here. So we open circle or solid circle? Solid. Okay, we need 1 more point. Can I plug in -2? X less than or equal to. So it's on the left side. Can I plug in -2? No. Plug in -4. And because it's x, we get -4. So, and then we connect them. We know it's a line. That's the first piece. So far, so good, everybody? Okay, and then keep going. Second piece. When x is between -3 and 0, do we include -3? Do we include -3? No. No. Do we include 0? Yes. -3 is a constant function. So it is, oh, okay. we put open circle, but because that point is already there, then you don't need to remove the point. We just connect them. That's the second piece. And then the third piece, do we include 0? No. And square roots. So we plug in 0, we get 0. We plug in 1, square root of 1 is 1. What is the next integer point? Square root of 4, we get 2. And then we connect them together. So this is the graph. Okay? We look at each piece, and then we put some points, connect them smoothly. But you know the shape. Line, like that. X squared, that's x cubed, right? Absolute value, and square roots, cube roots, so no practice the math. Okay. All right. Have a nice day. So Wednesday, I see you here at 9:55. Yeah, try to be here as early as possible, and then you can start the exam early.
Because I hate these, it's the same thing, but like, I'm just so scared.
Oh.
So it's like a lot of things.
Oh.
Like, I don't know this.
Oh, interesting. It's okay. You can keep it.
So, how?
Oh, okay, because it's x. Well, you need 2 points and fix the line.
Yeah.
Therefore, because it's basically less than or equal to -3, you cannot pick -2, then you pick -4.
Could you pick any number?
You can pick any number less than, yeah, you can pick -5.
Okay.
-6.
Okay.
Any number.
Okay.
Yeah.
Okay. So, like 2.3 and 4 are the example.
Right.
Okay. What is the like what sections of the example go?
Chapter 1, up to 1.7.
Okay, thank you. Just so I know, thank you.
I was gonna say, dude, I got a little bit class today, like, check with her.
Oh. Okay, thank you for knowing.
I have some questions about the
Sure.
exam.
Yes, sure.
What time is it?
At 1.
At 1?
Mm-hmm. Okay. Bye.